Okay, so here we have our ball bouncing now horizontally. We have our separate circle draw function. We have our separate rectangle draw function further down below. What we'd like to do now is get that ball that's already bouncing side to side to also move and bounce vertically. What we can do is really just follow the pattern we've already laid out for how to do it for the x-axis, right? We know that we're going to need an x and a y position and speed. Okay, let's say the ball y, let's start at the same 50. Ball speed y, let's give it a, I don't know, a little lower speed vertically, maybe 4. Not too terribly important. So this will go 10 pixels per frame over and 4 pixels per frame down. Remember that positive y is going downward in computer graphics spaces typically. Now for our movement code, we're going to clone what we've got for x, paste it right into the middle, which is going to make it easier to change these out for y's, ball y. So we're going to change the y position each frame by some amount. We're going to check and see whether or not that vertical position has gone outside of the top, which is less than 0, or the bottom, which is greater than height rather than width. And if so, then we're going to flip the vertical speed. Speed for the y-axis rather than the x-axis. And again, it's really just following the exact same pattern that we had for the x-axis. We're going to do it for that one too. And now the last and obviously important thing to be doing too is to make sure that where you draw the ball, we no longer have this hard-coded 150 number. Replace that with ball y. So as the number gets changed in code, just like the x coordinate does, it will be reflected in the position of the circle being drawn. And with those things updated, I'm going to save that, zoom back out, refresh the browser. Syntax error, unexpected token on line 34. This will actually be good for you to see me debugging this. Let's see here, feedback on... There we go. I click on that in my browser. Aha! And it's showing me right here where the error is. Pretty convenient. So let's go down to right there in our source. I'm gonna not edit this out because I want you to see that once again I make errors programming too, and it is just a normal, healthy, perfectly fine part of programming. I've added those parentheses back in, saved it, refreshed. Sure enough, there we go. And now we're in good shape. We've now got a ball that bounces on both axes. Moves up and down, moves side to side, bounces off the walls. We're already getting somewhere, right? I mean, how much more is there to add for gameplay to work? We need to be able to detect when it touches the wall, if it's where the paddle is or not. We need to be able to reset, want to draw the net, want to put up some scores, get a paddle on the right side. But like the most important part of this game, the moving thing in the center, now works. Pretty cool. All right, so we've now got the ball bouncing on its other axis. And next up, we're going to get the player's paddle to move based on where the computer mouse is. To do so, we have to look at where we're drawing that player's paddle. Currently, the Y position is hard-coded as 210. And we want to make that a variable so we can change it when the mouse moves. Just like we have a position for the ball, let's create a separate one called, I'm going to call it paddle 1Y, in anticipation of calling the other player's paddle, paddle 2Y. Doesn't terribly matter where we set it to, but let's say 250 as we know it's kind of like a reasonable distance down the screen. That's kind of our current position, if I'm not mistaken. Let's also simplify this code by saying paddle height. And I'm gonna change it up a little bit. Paddle height equals 100. So a const as opposed to a var means constant instead of variable, which just means that this number can't be changed while the game is taking place. It'll start 100, it'll stay 100. This allows us to base other decisions in our code on that, such as what's centered for the mouse or whatnot. Now, you don't have to do this. You could make a var. You could make this all lowercase and camel case, just like we do our other variables. I'm showing this here as an example of something where if we can assume that this is a constant throughout our game, then there's certain things we can do with it differently as we begin to do programming for math and spacing and positioning around the area that the player can see. You'll see also I've labeled it in all capitals and an underscore. It comes from cpound defines. But if you have a variable which is never going to change, it's nice to be able to label it in a different way that you then don't get mixed up into thinking you can set it later or change its value because you want to designate somehow it's a constant, treat it and handle it differently in your code, never assign values to it. So even though it's a const, I could call this paddle height and the code would work the same. I'm choosing, though, matter of personal convention and, like I say, old-fashioned convention, to put it in all capitals with an underscore instead of a space or an underscore instead of camel casing. And that will let me use its height in that way. Now we're going to need to add a new function for our mouse. The way that's going to look is pretty nasty, pretty gnarly, but bear with me. We have a function, calculate mouse position, EVT, var rect equals canvas dot get bounding client rect var root equals document element semicolon var mouse x equals EVT client x. As always, I'll explain this in a second after I've got it out on the screen for you to look at. Left minus root dot scroll left. Y's line will look very similar. Client y. Rect top. Scroll top. And in that case, then we can return a pair of values x, mouse x, y, mouse x, mouse y. So this falls in the category of the kind of code that we're normally not writing because it's using a little bit of special JavaScript chicanery. But all it's doing, it's really not as bad as it looks. We're going to have an event that fires every time the mouse moves. So the program's going to call a function every time the mouse moves. And that event is going to hand it the mouse coordinates it received as part of this EVT or event data. We're then getting the canvas's bounding client rectangle, which is the area that on our browser is the black rectangle we've been able to draw our game within. We're also getting a handle on the document, which is the HTML page, just like we got the game canvas off the document. And that's what this next math is doing for mouse X and mouse Y. It's taking the position it's getting for the mouse X and mouse Y, which are actually have nothing to do with our position in the canvas. Let me zoom out and show you what I'm talking about. If I just got the X and the Y value straight off of that event, it doesn't care where on the page this black rectangle is. It also doesn't care if, let's say, I scroll down to get to this game on a web page, it doesn't really care that I've scrolled. It'll always give me the same values. And so what we're doing is we're accounting for where on the page from the side or from the top is this canvas element, and how far have we scrolled in the browser. And by subtracting those out, we're getting the X and the Y coordinate of the mouse within the playable space. So that this will be 0, 0, and this will be 800 by 600, regardless of how much we had to scroll to get here, and regardless of where the canvas is located on the page. Now, lastly, it's returning 2 bits of information at once. Most of our return functions we're going to talk about or show or write ourselves later are going to be returning one variable at a time, because that's what most programming languages can do. There's some exceptions, Python among them, that return a pair of variables together. And this is basically just keeping our mouse code compact. It's keeping the X and the Y together. We've written that function, but unless that function is called somewhere, it doesn't happen. Here in window onload, we're going to write canvas.addEventListener. And here I'm going to say mouse move, comma, function EVT. And let's say var mouse pause equals calculate mouse pause EVT. That's the new function we just wrote. And then I'm going to say paddle1y equals mouse pause dot y. We'll get the y off of it that we returned. The way we handle input in JavaScript, and actually a lot of languages, ActionScript 3, so on, is you added what's called an event listener. That means that there's certain strings you can put here about mouse click, mouse down, key press, and so on, that you can then call a function whenever it's pressed. I'm then defining one inline right here as just a simple inline place, just like we did for set interval with move and draw everything. And all that function is doing is it's getting the EVT with the mouse's information, passing that in to calculate mouse position. That is then returning for us the X and the Y position of the coordinate based on, again, like the scroll and the position of the canvas on the page. And then it's getting the Y value of that and updating paddle1y to that number. Now, the last thing I want to show before we even look at the browser is you have to remember, every time we add these new numbers, you have to actually use it somewhere for that number to matter, or you're just changing a number in memory. You're just changing a value stored under some label. So I'm going to replace that as the Y value for the player 1 paddle right here, where it draws the white color rect on the left side. And if I scroll up and look at it one last time, I'm going to save it, Control S or File Save. I also see my some text here is bumping us over. Let's just get rid of that text. What do you say? About time we got rid of it. Some text here. There we go. And I'll zoom back out to look at the browser. And sure enough, the mouse moves the paddle. Now there's a little bit of a catch in that if I move my mouse real close to the cursor, and let's actually zoom in further, you'll see that it's actually dragging the top of the paddle and not the center of it, right? Which we probably want the paddle to stay centered on where the mouse is. Well, let's think about how we do that. Okay, if our paddle height is 100, what we're getting is the mouse Y coordinate. We want the paddle to have the same amount of height above the mouse as below it, or half of its height. Instead of setting it to exactly where the mouse's vertical position is, let's subtract paddle height divided by 2, or half the paddle's height. Remember that paddle height is being drawn as 100. In fact, let's make sure we're using that too, because I think we might not be. For the height of the player's rectangle paddle, let's put in this paddle height, which we define up above to be 100 anyway. And now this will subtract half the height of it from the position of the mouse as the top vertical position for the paddles. You'll see it's holding the center of the paddle now. And what's cool about using that divided by 2 and that filling in that constant in both places is that if I come back later and I decide I want to retune this game, let's say I find it's too hard, I want to make the paddle bigger, I can make this 250, refresh. Now I have a huge paddle and it still stays centered. Let's say I'm finding the game's way too easy and want a smaller paddle to challenge the player. Not a problem. I can make this 10, save it, refresh, and it's so tiny, but it's still, you can see it's still saying centered where the mouse point is, which is exactly what we want. As long as my mouse is inside the canvas. When I leave the canvas, it loses it. Let's put this back to a reasonable size of 100. But there we go. We have a player-controlled paddle. Now, it doesn't matter if the ball passes it, but we're getting somewhere, right? We have player control. We're accepting live input into the game. Pretty cool stuff.